Welcome to today's video. In this video, I'm going to look at equal matrices. So I'm going to talk about equal matrices, how you can identify equal matrices, and also describe equal matrices. Okay, so when can we say matrices are equal? So matrices are equal when one, they have the same number of elements. Okay, that is one factor that determines whether the matrices are equal or not. They can be 2, 3, or 4. You can compare as many as maybe can be or you want, but one factor you should check among all or between two matrices is whether they have the same number of elements in them. The other point is the corresponding elements are equal or the same. After you compare the number of elements the matrices have, if they are the same, you can go further and check whether the corresponding elements are equal or are the same. Okay, so these two factors, if they are fulfilled, then that means those two or more matrices are equal. But if they are not, then those matrices are not equal. Okay, let's identify equal matrices. So below here are some examples of some pairs of matrices. In these examples, I've just used pairs to simplify my explanations. But these matrices can be a pair, a group, which maybe can be 3 or 4. They can be as many as maybe even 100, depending on the information you have kept. Okay, so now let's start comparing. Let's start checking whether these matrices are equal. So when you are checking, when you are trying to identify whether the given matrices are equal, what to take in account are the position and the number of elements in the given matrices. Okay, let's start with example 1. Example 1, there are two matrices given. So let's start by checking the number of elements each matrix has. So you notice that both matrices have 2 elements inside them. So that means the first criteria or the first point has been fulfilled. They have the same number of elements. Now let's come to position, or let's come to the corresponding elements, that is the position. Okay, let's see. We have the element that is occupying position 1,1. If you are not conversant on how to identify the position of elements in a matrix, you can watch the video. I've put the link in the description box where I taught about position of elements in the matrix. How do you identify the position of elements in a matrix? So you can check on that video. It will tell you how to identify the position of an element in a matrix. Okay, so now let's check. So we have that element in the first matrix which occupies position 1,1. Let's also check the element that occupies position 1,1 in the second element. So we have that one. Okay, so in the first matrix, the element that occupies position 1,1 is 1. In the second matrix, the element that occupies position 1,1 is 4. So these two numbers, they are not equal. Therefore, I cannot even go further comparing numbers. Already, the numbers that occupies position 1,1, they are different. That means these matrix matrices are not equal. So these matrices are not equal. Why? Because the corresponding elements are not equal or same. Okay, the reason I've used equal or same, because in other books you may find it's written same, in others you find that it's written equal. So equal and the same, in this scenario they mean the same thing. Okay, so we can say that matrix, those two matrices in question 1, they are not equal. So let's go to example 2. Okay, so example 2, we are given two matrices. The first matrix has 6, 9, and the second matrix has 6, 9. So let's check whether these matrices are equal. So the first thing, we're going to count the number of elements in each matrix. So the first matrix has 2 elements and the second matrix has 2 elements. So the first point has been fulfilled. Now let's come to the second point where it says the corresponding elements should be equal or same for the matrix to be equal. Okay, so let's check the element that occupies position 1, 1. So 1, 1 in the first matrix is 6. 1, 1 in the second matrix is also 6. Okay, let's check the element that occupies position 1, 2. Okay, so the element that occupies 1, 2 in the first element is 9. In the first matrix is 9, and the element that occupies 1, 2 in the second matrix is also 9. Therefore, we can say these two matrices are equal. So they are equal because they have the same number of elements and corresponding elements are equal. So these two matrices, we can say they are equal. Like I said earlier on, if you don't know how to identify position of elements in a matrix, you can watch the video. I've put the link in the description box so that it can help you to understand the position of elements in a matrix. Okay, let's go to example 3. Okay, so first thing, we're going to count the number of elements these two matrices have. So you can see that matrix 1, the first matrix has 4 elements and the second matrix has 4 elements. That means the first point has been fulfilled. Let's check the second point, which is the corresponding elements are equal. Okay, so let's start with 1, 1 elements in both matrices. Yeah, so we have 1, 1 is 1 in the first matrix, and 1, 1 is also 1 in the second matrix. Let's go to 1, 2 elements which occupies position 1, 2, which is 1, 2 in the first element is 4, and 1, 2 in the second element is 4 as well. Okay, we are done with the first law. Now let's come to the second law. So let's check the element that occupies 2, 1. The element that occupies 2, 1 is 2 in the first matrix, and the element that occupies 2, 1 in the second matrix is as well 2. Okay, now let's check the element that occupies 2, 2 in both matrices. So the element that occupies 2, 2 in the first matrix is 7, and the element that occupies 2, 2 in the second matrix is 8. Okay, so as you can see, 7 and 8, they are different, they are not equal. So here in this example, there is also another lesson you should learn. When you are trying to find equal matrices, don't just check the first law. Even if they are matrices that have maybe 3 or 4 rows, you make sure you check every element in each row so that you are sure that the matrices are equal or not. Take for instance, if I just check the first row and I see things are flowing okay, and I could have just guessed to say they are equal. Meantime, the last digits in each matrix are different. So that will make me to get a wrong answer. So you check every element in the given matrices. So we found that 7 and 8, they are different, they are not equal. Therefore, we can say these matrices are not equal. These two matrices are not equal. Okay? Now, I've shown you how to identify equal matrices. I want you to pause this video and also to identify whether the pair of matrices in 4 and 5 are equal. Try to check whether the pairs of these matrices in 4 and 5, if they are equal. So please pause the video and try to identify whether these matrices are equal or not. Okay? Now, I'm going to take it that you pause the video and you tried to check whether these pairs given in 4 and 5 are equal or not equal. Okay? So, I also expect you to write your answers in the comment section. Let's get interacted. Let's start interacting, because that will help us in our learning. I'm going to understand whether these videos are impacting your life positively or negatively, so that if it's negative, I can improve, and if it's positive, I can continue with what I'm doing. Okay? Now, here I'm not going to go around circling every number, because I presume you have gotten the concept of what we are doing. So we counter check together. Let's start counter checking. We'll start with number 4. Okay, the number that is occupying 1, 1 in both matrices is 7, so that one is okay. The number that is occupying 1, 2 in both matrices is 2, then that means they are equal. The number that is occupying 2, 1 in both matrices is 4, that means they are also equal. The number that is occupying 2, 2 is 0 in both matrices, so they are also equal. Therefore, we can say these matrices are equal. They are equal. Okay, let's go to example number 5. Okay, so we can counter check. You can see that the the number that is occupying 1, 1 in both matrices is 2, so they are equal. And 1, 2 in both is 1, so they are equal. 1, 3 in both is 0, so they are equal. 2, 1 in both is 3, so they are equal. 2, 2 in both is 7, they are equal. 2, 3 in both is 4, so they are equal. 3, 1 is 5, they are equal. 3, 2 is 8, so they are equal in both. And 3, 3 in both is 6, so they are equal. And that means these two matrices, they have got the same number of elements and corresponding elements are equal. Therefore, we can say these are also equal. Okay, just like I said earlier on, if you are confused on how to identify the position of elements in matrices, you can still go in the description box, check on the video where I talked about position of elements in a matrix. So basically, this is how you can identify whether the given matrices are equal or not. Thank you so much for watching. If you haven't subscribed to our YouTube channel, we invite you to subscribe to our YouTube channel and invite your friends to subscribe to our YouTube channel. Help Easy Learning Z to grow. We will really appreciate that. And if you found this video helpful, remember to like it and also share with your friends. Thank you so much for watching. God bless you.